The contents of this presentation. My goal will be to walk through the example use cases we have here at DoorDash and optimizations we made to ensure that they scale properly. In particular, the two use cases I want to cover, the first one is the MX Portal ads campaign reporting. That's a customer-facing use case that shows DoorDash merchants how their ad campaigns are performing. And the second one is risk platform dashboarding. This is an internal use case which helps one team in particular, our risk and fraud team, visualize their platform metrics in real time. So sort of similar to the Stripe use cases. Before I get into that though, an overview of Pinot at DoorDash. We have a single cluster with 3 controllers, 21 brokers, and 58 servers. It's multi-tenant, so we use like the tenant feature Pinot provides, and we currently have 18 corresponding to different use cases. The single cluster definitely has some trade-offs as opposed to running multi-cluster, but for that we deploy on Kubernetes with Helm. Helm provides like the chart that you can use to spin up resources, and to kind of support like different tenants, we use multiple Helm releases to provision resources for like a tenant specifically. The customer-facing use cases, we have multiple, but they all go through like a single UI, which is the MX Portal. I'll talk about that a bit more shortly. And internal analytics use cases, they mostly revolve around dashboarding performed by our product and operational excellence teams. And most of that is motivated by the real-time ingestion capabilities of Pinot, as well as low query latency. Cool. So the first use case, MX Portal ads campaign reporting. Yeah, so the product behind this, the DoorDash MX Portal, MX is short for merchant, shows merchants how their business is performing. So this can be things like, how many orders did I get today, or like which menu items are popular. And one feature that is there in particular is the ads campaign reporting tab. And so DoorDash merchants can run ads, and that shows up when like consumers like me order. And this tab in particular for merchants who run ads, it shows their conversion rate. And so like kind of the life cycle of an ad is like there's an impression or like a view, and then a user may or may not click on it, and then they may or may not make an order. And so yeah, here on the right you can see kind of what this looks like. And in Pinot, what this translates to is 3 hybrid tables. They're called, in this case, ad view, ad click, and CPA, corresponding to the impressions, the clicks, and the orders. As you can see in the right, in the Pinot tables page, the size of the ad view table is obviously the largest. The size of the ad click table is going to be quite a bit smaller, and the order table is going to be even smaller than that. But yeah, the reason why we went for this hybrid table approach is the real-time table provides minute level freshness and whatnot. But we found that the offline table generally provides more stability, as well as you can do some post-processing such as deduplication if you want. So that's why we have that hybrid table set up. And what the queries look like from the MX portal, typically what they do is like we're interested in a single merchant business or like a store corresponding for that business. So there's going to be some like where filter, and they want to aggregate like metrics such as the sales, or like, in the case of just the impressions, it's just like a count query. And in terms of like the indices that we use, we use an inverted index for this because typically for like a merchant, there's only a few number of rows. Like you can think like in orders, how many orders is a merchant going to get a day? It's like probably in the number of like hundreds or maybe thousands, but not too much more than that. So in our case, we thought the inverted index was perfect, but for heavier use cases, I could see why you'd want to use, like, for example, the StarTree index. And so that was all like good and dandy when we first set it up. But one problem that we ran to as things scaled was that as the data volume grew, the number of segments in the table grew. But that also meant that the queries for like a business or store had to essentially read more segments. Pinot publishes Prometheus metrics, and so here's one that kind of corresponds to how many segments are being like processed or read. And there's kind of like a periodic trend to it, so it's hard to tell, but it kind of goes from around 400 to closer to 1,000 over the span of a few months. And this contributed to a few latency issues we were seeing with the product. The solution for us involved a key fact, which is a query only involves a small number of rows because it only corresponds to like one store or business at a time. And like that number of rows is going to be in the thousands, and that can entirely fit onto one Pinot segment. So theoretically, there shouldn't be a reason why we're scanning over or reading a bunch of Pinot segments. The reason that happened though was in the beginning, we didn't make any effort to make sure that all the rows for like a business or store was on one segment. And so the solution was to co-locate them. All data in Pinot is of course time-based, so it's going to be like for a single date or a single date partition, the segments that correspond to that, you're going to try to co-locate the rows for that, just one partition. And how we ended up doing this was through sorting the rows within a date partition by their store ID. There's different ways you can kind of do this in Pinot. You can do like partitioning, like people do like modulo and stuff like that. But sorting worked well for us, and it's relatively easy to do because when you're exporting data to Pinot, you can just add like some order by statement, and it does it for you. Cool. Another problem that we kind of ran into, also as data volume grew, was that we saw increased disk reads. This was particularly the case. As I mentioned, the tables are hybrid, so there is that like data load that happens daily for the offline table. And during those offline loads, we saw our latency go up. And yeah, that was also due to the disk reads. So kind of like some more context on that. In Pinot, segments are memory mapped. So when they aren't in memory, they need to be paged in. And a little bit of paging is fine, but if you're reading a lot of segments from disk and you're having like, hundreds of queries per second, you're gonna see high latency. And so the solution for this problem was while data loads was what kind of caused the spikes in our latency, we realized that a contributing issue to this was the fact that the real-time table was using more memory over time. And it was using more memory over time because that's also like a consequence of the increased data volume. The graph at the bottom kind of shows it's also kind of hard to see, but we're using more memory over time. And so what we did to solve this was to separate real-time and the offline servers so that like the real-time table is on one set of servers and the offline table is on a different set of servers. And that change actually had a like significant improvement on latencies. So yeah, this one was definitely very important. Cool. So yeah, that's a little bit about the merchant portal use case. I'm now going to talk about the risk platform one. So yeah, basically we have a risk or fraud team at DoorDash, and they own a platform to determine things like bot signups. And internally, they wanted to monitor the metrics on their platform in real time. And so Pinot was like a perfect kind of candidate for that. And what they did was they ended up building dashboards in Superset on top of Pinot tables. And some example tables kind of looks like this. They also went with a hybrid approach. The tables contain like metric or event data that they're interested in. And then the queries from Superset, what they'll do is they'll just aggregate these metrics. It might look at like a slice and dice. It might look at a specific dimension, and it will do it over like different time windows and granularities. One kind of interesting thing about this is, so these are like charts in Superset. So you might, like one chart might be like, oh, the past hour, one chart might be the past 7 days. And in each case, like the data points that you're plotting at are a little bit different. So like for the hourly chart, it might be like, minute level plot data points. But for the 7 days one, it might be like just hourly or daily. So what we kind of realized was like in Pinot, you have like a time column, but that time column might not be good for graphing at different like granularities. So we created multiple time columns so that query in Superset was sped up. And so it's you're kind of doing a little bit of like pre-computation or pre-aggregation a bit. Cool. But yeah, the main thing I wanted to talk about with this use case was like kind of optimizing its resource usage. So while Pinot provided value to the fraud and risk team, due to the table volume, it required like 6 servers to host, and that was a bit much. But kind of like one key fact here was the team was most interested in like the recent days data, even though the full table might have had like 90 days worth of data. And so we were able to kind of resolve the high resource utilization issue by onboarding to tiered storage. And this reduced our server count to 2 from 6. And you can kind of see on the right, like the instance count and showing the number of segments on each server. And then the first one is the tiered storage servers. And those are actually pulling from S3 when they query the data. Cool. In conclusion, Pinot is a great technology that has allowed DoorDash customers to receive analytics in real time with sub-second query latencies. But to ensure that the performance has been good as we scaled, we found that both our users, so like the product teams, as well as us, need to be aware of details such as how the data is laid out, and as well as things like memory and disk usage. On the internal analytics front, Pinot can provide snappy dashboards with sub-minute freshness. But one thing we're thinking about is like the speed / resource cost trade-off, because these things do require servers to host. So that's something to consider. Cool. Thank you for listening.
For the Superset interaction, and that's mainly going to the product team that's interacting with that then?
Yeah.
Do you find, are there often questions coming in of a chart or visualization or some sort of calculation that the current table structure is unable to answer? So, I mean, you talked a little bit about we pre-calc or pre-truncate the timestamp in order to get performance. What about other dimensionality? Is it always just a timestamp on the x-axis, or is there other kind of slicing or dicing that they're trying to do that you're kind of limited by on the Pinot data model?
So I think mostly it's been like the timestamps that have been the issue. I think sometimes people, they're like Kafka topic, like the data is in like some JSON format. It's like not flattened. And so they need to have like either a Flink job or like an ingestion transformation in the Pinot table to like flatten out before they have that, before they create that dashboard in Superset. But so far, I don't think we've run into any things. Yeah.
I was curious about one of the problems you mentioned about growing data sets, especially for real time, and how that caused degradation overall. Do you see any other problems with growing data sets, and is data retention on your mind a strategy for deleting older data? Is that something that your team is actively thinking about?
Yeah, so on like data retention, so like a lot of kind of like the product teams, they want to say like, oh, we want our customers to be able to query like anytime in like a 5-year window. And while that's really cool, like in terms of like a product feature side, like it's a little more challenging because when you like, yeah, enable this huge data ranges, like you have to store more data, but also like, you know, querying like data that hasn't been accessed recently will pull it from disk, and that might be a little bit slow and stuff like that. So far we've kind of been talking with our product teams, like say, what if like for data in the past, you have like a separate table that's actually aggregated, so it's a lot smaller and stuff like that. But we've definitely like tried to like draw the line where like, yeah, we can't have like this much data, or else you're gonna see performance problems too in your product.